So in this video, I'm going to show you how to integrate with partial fractions. And I'm going to assume that you know how to use and work with partial fractions. If you're not sure about this, you can check out the lesson and video on my website, mrmathematics.com. Okay, so the first thing we've been asked to do is to express this fraction in the form of a over x minus b plus b and x plus 3. So we need to begin by factorizing out this denominator. So we have 12 over x minus 3, then x plus 3. So we have a difference of 2 squares here. And this is equal to a constant a over x minus 3 plus a different constant b over x plus 3. And now I'm going to multiply everything by x minus 3 and x plus 3, because then this will cancel on the left-hand side. So these will cancel. So we have 12 is equal to, these will cancel. So we have a lots of x plus 3, and this will cancel with this. So we have b lots of x minus 3. And now I'm going to work out the value of a by making this term equal to 0. So I'm going to say, let x equal 3. So now we've got 12 is equal to a. Then we've got 3 plus 3, which is 6. So 6a. And 3 take away 3 will make 0. So that will go. And therefore, a will equal 2. And now I can work out the b term by letting this one equal 0. So we can say, let x equal minus 3. So now we have 12 is equal to minus 3 take away 3 will become minus 6b. So therefore, b will equal minus 2. So this is equal to a, 2 over x minus 3, minus, so I'll change this plus here to this negative, 2 over x plus 3. Okay? So that's part A sorted. So now we're going to move on to question B. Okay, so in question B, we've been asked to integrate this, but this as it stands, it is very difficult to integrate unless we can write the same expression using partial fractions. So what I'm going to work out is the integral between 11 to 4 of this expression with respect to x, because this is exactly the same as this. So now I'm going to break this up. We'll do this in blue and we'll do this in green. So we have the integral between 4 and 11 of 2, but I can move this 2 in front of our integral sign because it's a constant. So 2, and the integral of 1 over 3 over x minus 3 with respect to x. And when I integrate this, we get 2 lots of the ln of the magnitude of x minus 3. Okay? And the reason why we're not multiplying this by anything or scaling this by anything is because the derivative of this in a function is 1. So this is the integral of this. And the limits are 4 and 11. So for our next one, we've got minus 2 times the integral of 1 over x plus 3 with respect to x. And this is, again, minus 2. And then we have the natural log of x plus 3, again, between 4 and 11. There's no constant term because this is definite integration. Okay, so I'll put these back together for our final integral. So we have 2 times the ln of x minus 3 minus 2 times the ln of x plus 3, all between 4 and 11. So I'll substitute in our limits. So we've got 2 lots of ln. Then we've got 11 minus 3, which is 8, minus 2 times the natural log. We've got 14 here. 11 plus 3 is 14. So we'll learn of 14. Minus, we'll be substituting the 4. So 2 times the log, natural log of 4 minus 3. So 1 minus 2 times the natural log of 4 plus 3, which is 7. So I can factor out the 2 and use the division rule. So we've got 2 times the log of 8 over 14 minus 2 times the natural log of 1 over 7. So we'll move this over to here. I can now factor out the 2. So we've got the ln of 8 over 14 over 1 over 7. And this works out to be 2 times the natural log of 4. Okay? Let's move on to question 2. Okay, so for example 2, we've been given this function in terms of k, where k is a positive constant, and we've been asked to express the function in partial fractions and then to evaluate this integral here. So the first thing we'll do is we'll write the fraction x plus 3k over x plus k times x plus 2k, and this is equal to a over x plus k plus b over x plus 2k. So now we'll multiply every term by this denominator. So we get x plus 3k is equal to a x plus 2k plus b times x plus k. Now, like we did a minute ago, we'll make each of these brackets equal 0. So we'll say let x equals minus 2k. That will cancel out this bracket. So we've got x, which is minus 2k, so minus 2k plus 3k will equal 0a, and then minus 2k plus k is minus k, so minus b. So therefore, b will equal minus 1. Then we'll let x equal minus k. So now we've got minus k plus 3k, so 2k. And this is equal to minus k plus 2k, which is k, so ak. And then this will cancel. So therefore, a will equal 2. So our partial fractions become 2 over x plus k minus 1 over x plus 2k. Okay? So this is this function in partial fraction form. Now we need to integrate this partial fraction form to carry out this integral here. So again, I'm going to carry out each of these integrals separately. So we'll have the first one, the integral between k and 3k. And because this is 2 on the top, a multiple of 2, we'll bring up a 2 to the front, and this will be 1 over x plus k with respect to x. When we integrate this, we get the natural log of x plus k between k and 3k multiplied by 2. So for our next one, we've got minus the integral of 1 over x plus 2k with respect to x. So this will be the natural log of x plus 2k between k and 3k. So putting these two together, we have 2 times the natural log of x plus k minus the natural log of x plus 2k between k and 3k. So now I can simplify this using my product and division rules. So we have a natural log of x plus k squared over x plus 2k between k and 3k. We'll substitute in our limits. So we've got the natural log 3k plus the k is 4k. Squaring this is 16k squared over 3k plus 2k is 5k minus the natural log of now k plus k, which is 2k. 2k squared is 4k squared over 3k. You can see that one of these k's will cancel with this one. So I'll just eliminate that and eliminate that. And again, on the other expression here and here, so I'll eliminate that and eliminate that. So then we have the natural log of 16k over 5 divided by 4k over 3. And this will simplify to make the natural log of 12 over 5. Okay, so thank you very much for watching, and I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. Thanks again, and take care.